Okay, the second part of the chapter, acid-base theories. In general chemistry 1, you will learn about 2 out of 3 theories of acids and bases. The third theory of acids and bases you will learn in general chemistry 2. Let's work with the first one, Arrhenius theory, and then we will continue with Bronsted-Lowry theory. The first, simplest, and so far the weakest theory of acids and bases is called Arrhenius theory. So, according to this theory, an Arrhenius acid is a substance that produces hydrogen ion, which we show with H+, when it dissolves in water. And base is a substance that produces hydroxide ion when it dissolves in water. So the weakness of this theory is because we are dependent on aqueous solutions. We need to have an aqueous solution. But what if we don't have an aqueous solution? An example of an Arrhenius acid is HCl, which releases hydrogen. When it dissolves in water, we need water, of course, here. And an example of a base, an Arrhenius base, let's say it's NaOH. When it dissolves in water, it's going to form sodium ion and hydroxide ion. So you see, we said Arrhenius theory is the weakest because of the type of solvent that it represents. It's just the water, and we cannot work with this theory in any other solutions. So we have a better theory, but that I'm gonna go over it in a few minutes. But before that, on your PowerPoint slides, you have a list of very short list of 6 strong acids and 6 strong bases. I prefer to keep them in mind, to memorize them. Whatever else is not on this list is going to be either strong acid, weak acid or weak base. So, memorize the strong acids: nitric, sulfuric, and perchloric acid, hydrochloric, hydrobromic, and hydroiodic. For strong bases, you have the bases of some of the metals from groups 1 and 2. Lithium hydroxide, sodium hydroxide, potassium hydroxide, and in group 2, calcium hydroxide, strontium hydroxide, and barium hydroxide. So you have 6 strong acids listed for you here and 6 strong bases. It's better to keep them in mind so you can easily distinguish between weak acids and bases from strong acids and bases. So keep it in mind until we need them again. Bronsted-Lowry theory is the second theory of acids and bases. According to this theory, an acid is a substance that releases proton. Proton is the same hydrogen ion. Why we call it proton? Because hydrogen has only 1 electron, right? Whenever it loses its sole electron, it will have only 1 proton. So that's why we call it proton. So substances that donate proton to another substance are called acids. So you see, we are not talking about the type of solvent anymore. We don't have when it dissolves in water. So it makes this theory stronger than Arrhenius theory, right? For Bronsted-Lowry base, we call it a substance that accepts the proton or hydrogen ion from another substance. If we have a donor, we must have an acceptor, right? It's giving and accepting. So I would like to work on this theory with an example. But what is important in this theory is the concept of conjugate acid-base pairs. Conjugate acid-base pairs are species of the same substance. This is the format for the base, and this is the format for the acid. So if you pay attention, their difference is only one hydrogen. Okay? For example, if you have H2S and HS, can I call them a conjugate pair? Yes. If you have NH4, let's work because we have the base first. NH3 and NH4, can I call them a conjugate acid-base pair? Yes, 3 hydrogens and 4 hydrogens. But how about this one? What if I have sulfide and H2S? Can I call them a conjugate pair? No, because the difference here now is 2 hydrogens. So in order to be a conjugate acid-base pair, we definitely must have only one difference between the hydrogens of acid and base. Okay? Now, the questions on bromocellularic acid and base are normally an equation is given, and you're supposed to label the acids and bases on each side and then the conjugate pairs. So let's start. We need to compare the two sides of the equation. Go from NH3 to NH4OH. What is happened to, let me just eliminate the OH from here because I don't want to confuse you. So I guess that looks better now, right? So NH4 and NH3. What is the difference between these two? 1 hydrogen. But going from NH3 to NH4 seems like NH3 has accepted a hydrogen, right? According to the definition for bromocellularic acid, this should be a base. It's a proton acceptor, right? On the other side, if NH4 donates a hydrogen, goes back to the form of NH3. So on the other side is acid. NH4 is acid. And I can call this pair a conjugate. Let me write it on top. Conjugate just pair. Acid-base pair. You know acid-base. Conjugate pair. Right? Between H2O and OH, what happened? I'm sure you will say, it seems like H2O has lost 1 hydrogen to change to OH. So according to the definition for bromocellularic acid, H2O is acid, and OH on the other side is ready to grab 1 hydrogen and go back to H2O. So this should be the base. And now you can call these two a conjugate pair. Conjugate pair. Right? So that's how you approach the problems of bromocellularic theory. You will find out the acid and bases and then their conjugate pairs. Another point is that on one side, one of them is definitely acid, one of them is base. You cannot have 2 bases on the one side and 2 acids on the other side. On each side, you must have 1 acid, 1 base, the same on the other side. The species which is base on one side is acid on the other side, and the species which is acid on one side is the base on the other side. Okay? So I hope you learned these 2 theories well. Please try to learn them well, especially if you're going to General Chemistry 2. Then we will introduce Lewis acid-base theory to you, which is based on electrons, no hydrogens anymore. I hope you learned it. Work on enough examples and worksheets and let me know if you have any problems.